pleasure to be here today to present on a topic on robotics simulation along with my tech journey. So let's start. Just a brief introduction here. So today's talk covers a sneak peek into who I am, what I do, my tech journey, a brief note on what are the challenges I have faced and how I have overcome them through this tech journey. And then I would move over to talk about Ocado technology, how we use simulations in robotic pick and place. And then briefly I'll try and finish off with some discussions on how and what sort of processes that we use within my team, which is the Robotics Simulation team, to build new features. So that's the plan for today. Before I go any further, let me introduce myself. I am Tafline James-William, aka Taffy James-William, as someone calls me Taffy as well. I manage the robotics simulation team at Ocado. I am a software engineer, a technologist by profession. I specialized in AI, sim, and performance analysis. A full-time working mom of 2 kids. They are here in the audience today to cheer me up. Thank you. A woman in leadership. I'm also a coach, a mentor, a creative thinker, a dreamer, I would like to say, a bibliophile, don't know how many people knows this, a person who loves books, a melophile, I learned this new word. I don't know if any one of you knows what a melophile means. Yes, that's right. Yes, a person who loves music. I think those are the things that keeps me calm and relaxed on a stressful day. And this is who I am. Basically, all of these is who I am. And now I'd like to move on to what I do. So let's start with the first one. I manage and lead the robotics simulation team. What does it mean is we build simulations that validate and test robot pick. And I lead a multicultural, multilingual, multinational, and in short, a diverse and high-performing, effective team. And I'm really proud of my team, guys. Let me say that. So what does my role involve? My role involves supporting my team and my senior engineers on technical decisions. So it's technical leadership. I do manage stakeholder expectations, so users who use our simulation, their requirements. Also, to ensure that we deliver on time any new features that they would like. I work very closely with our product managers to contribute towards the long-term vision and roadmap of our product that we build. In charge of team process management. So what is team process management is I ensure required processes and team rituals are set up so that it improves team efficiency and performance. This also involves eliminating any redundant tasks or processes. With project management, I'm in charge of planning, organizing, execution, and also delivery, which is completion on time, the work that we pick up. Then there comes team management, which involves creating an environment, a team that's built to collaborate and work well together, which is quite important these days. You have to work well with each other in order to deliver innovative things. And finally, there is people management. So with people management, it also involves conflict management, resource management, career growth of engineers, development plans, and all of the above. So these are some of the many hats that I wear in the current role. And I'd like to simply go over how I started all this, where and how this journey started. So that's my tech journey. How did it start? It started when I went to school at Holy Cross Anglo-Indian in India, where I was taught Impossible simply means, anyone? Impossible simply means, I am possible. So yes, I was taught that in a convent. And also to believe that our future belongs to the beauty of our dreams. It's by Eleanor Roosevelt as well. So those things, I had this amazing sister, a nun, who was passionate about it, and I believed it. So I started dreaming. I followed my dreams. I studied bachelor's in computer science and engineering, topped with the university second rank. I then secured the British Chevening scholarship and went ahead to Imperial College to do my master's in advanced computing, specializing in AI and robotics. Now, after graduation, I learned a hard truth, which was the roles in AI and robotics were so scarce, and none without a PhD, and I was a woman in tech as well, so obviously much more scarce. So I had to make some choices. I did. I joined a company known as ClarityBlue as a graduate software engineer sometime back in 2006, which was bought over by Experian. I did several roles. I was a software engineer, I became a lead, a senior engineer, and then moved on to do several roles in leadership, architect. I also then joined Sky, which was bought over by Experian. So over the 13 years, I did several roles, gained a lot of experience, and moved up my career. Now, in 2019, my then three-nager, I don't know if anyone knows what a three-nager means. So this is a person who is 3 years old but behaves like a teenager. So I have a teenager now as well. So this person now becomes really unhappy with my long commute and busy schedule. So I have to make some decisions now, some choices. I used to cross this online grocers where I live every day, but I never looked up on it, on what this place is, until a friend of mine encouraged me to apply to this place 5 years ago. So no looking back. An amazing journey started there with Ocado, which I'm really proud of. So I just wanted to briefly also talk about the challenges along this entire tech journey and how I continue to overcome them. For one, it's demanding work-life balance with kids. There's a lot of juggling there to do. The way that I have learned to handle it is with setting the right priorities. The method that I use is the jar of life. I don't know if many people have heard about it, but I'm happy to talk about it during the question session. I also found the place of work and work culture heavily contributes towards a fulfilling career and work-life balance. Choosing Ocado over one of the other lucrative and higher position role was my way of finding the work-life balance that suit my and my family's needs. As I said, I've had my fair share of failures and disappointments, delayed promotions due to pregnancy and childbirth, missing opportunities due to child health issues, so on and on. So how do I face them was by cultivating an undying positive spirit and to look at every challenge as an opportunity to thrive and work harder. Being a woman in a male-dominated industry can be daunting, especially with fewer role models. And my way of flourishing is by building a support system, both personally and professionally. I am blessed to have people like Dr. Radhika, who's here with us, Laura Cumming, she'd be in the panel later this afternoon, both are from Ocado, to have them as my support system to cheer me up during ups and downs. So building that support system is quite important to me, and I'm blessed to have that. The next one, I think I quickly went over, was a fastly evolving tech. I don't know if you all are in university. I mean, for us, we feel ancient sometimes, outdated, because the tech actually moves quite faster. And one way of coming over it for me is to be consistent and plan and at least spare an hour every week so I can keep up with my super intelligent team. So a new day, a new chapter in your life, and it's in your hands. That's how I've been overcoming these challenges and coming over. One of the best things that happened along my journey was from I started in data warehousing, I was able to move back to my passion, to where it all started, the dream to work in robotics. That's why I studied advanced computing in the first place. So, and Ocado gave me that opportunity. So who are Ocado Technology? I don't know if you guys have like Googled up, you know about it. Definitely you must have seen some vans going past by, but we are not only online supermarket. So who are we? We're much more than that. Technology pioneers. We're looking at some of the technology, the toughest technology challenges of our age. For over 20 years, Ocado has been looking at transforming online grocery and beyond using cutting-edge innovation. Today, we have 2,500 strong technologists across 8 countries developing industry-leading capabilities across both software and hardware engineering in automation, robotics, AI, machine learning, data science, and much more. And we also own about 2,600 patents along the line. So a little bit more insight on what we do. So our specialists build and maintain the pioneering automated technology platform known as the Ocado Smart Platform. We call it OSP. Rather than buying off-shelf technology to support our needs, we built our own because the ones off-shelf was not fit for purpose. We built and licensed those technology for retailers around the world. We still consider ourselves a 20-year-old startup, and it's our way of building the technology and changing the world. So let's see what we actually do. This is the Ocado way. The conventional way, you can see, is through regional distribution centers, the conventional stores, and then it reaches the customers. The Ocado way is we have a center fulfillment where we have the Ocado Smart Platform. So what makes Ocado way of doing grocery different? Grocery is the most difficult retail segment to deliver online profitably. The hard problem here is it is a big basket, varying storage temperatures, short life of the products, low margins, low tolerance for substitutions, and high expectation on on-time delivery. So we went into this new approach. Most companies have bricks and mortar retailers who provide an online channel. However, Ocado does online-only supermarket. And how do we do that? We have the Hive. So what is the Hive? It is a highly automated warehouse. Thousands of bots whiz around the top of the grid of storage bins arranged in stacks. So if you see, all of those are storage bins, and then you have bots moving around. The Hive is the world's densest automated storage system that we know of. These bots orchestrate as a swarm. For example, if a bot needs a tote that is on the 4th from the top of a given stack, other bots will remove the top 3 bins, then it can grab the 4th one it wants. And then it takes to the picking system. It could be a manual picker, or now we're going to talk about the on-grid robot pick. So this is where it is. This Hive is massively scalable and enables huge efficiencies and superior economies. And that's where we go into robot picking and packing. Picking and packing is one of the most complex challenges in automating online grocery, because one arm must be able to pick 50,000 or different products without prior knowledge of what it is picking. This is very different to robots in automated industry, where one robot is built to do a specific task. There are a lot to consider here. the arm has to grasp and manipulate of varying shapes and sizes. So the way we approach the problem is through the development of an advanced robotic picking system that uses a suction cup. This robot picking system is used at Erith in one of our warehouses. So that's the on-grid robotic pick, if you can see there. And let me see if I can get to...
Tens of thousands of products of varying shapes, sizes, weights and fragility, and pack them densely in bags with human precision and accuracy. Rigidly programmed robotic systems that are used in other industries are simply not fit for purpose for the unique demands of the grocery space. On-grid robotic pick combines cutting-edge machine vision, deep reinforcement learning and advanced sensing to pick and pack grocery items without any prior knowledge of what they are, making smart decisions on the fly. On-grid robotic pick integrates with our Hive solution and collaborates seamlessly with all Ocado bot fleets to fulfill customer orders without human touch, directly from the grid. Being able to pick directly from the grid opens up new opportunities to optimize warehouse design, enabling unmatched capital and site efficiency.
So that's on-grid robotic pick. It uses the Hive and it uses the arm. Now, how is my team supporting this? We have a lot of simulation in Ocado, but mainly we use simulation, modeling, and digital twins. Now, if we want to scale the amount of hardware to build a robot pick, then we need to simulate it, we need to test it, we need to validate it. So we've developed an expansive suite of simulation tools to architect, test, and optimize our systems, which involves simulation, modeling, and digital twins. Now, this is what my team does. We simulate, test, and validate. For example, the little things that we do is barcode scanner position evaluate. So when we do a pick from a tote and place it in one of the customer bags, before that we need to scan the barcode, setting up hardware for all of these test cases while we are innovating and building is quite costly. So building them as simulation using CAD models, URDFs, precisions, photorealism enable us to go an inch further in our innovation. So if you see the video there, that's what my team does. So my team is involved in building all these hardware. We simulate real hardware. We simulate the arm, we simulate the sensors, we simulate the camera, and the pick and place, if you can see there. So what does it aid? It aids with development and test cycle of the robotic picking. We also do synthetic image generation. So for example, if we were going to do like large amount of pallets and enable us to learn from machine learning data, we use the synthesized image there on the data there as well. We also use to test use cases and evaluate assumptions so we can do future prediction analysis. So that's what that comes in, simulating and testing and validating. And my team is the one that builds this internal product. Like we said, we're not using off-the-shelf technology, we build the technology ourselves. So I'm going to go over, conscious of the time, so I'm going to quickly move over to how we actually build these features into the simulation. So the feature development lifecycle within my team. So first, I go and find out, me or my product manager, we go and find out what is the problem that we're trying to solve and how can we solve the problem. We might also have like use cases from our different users. Our users are other teams who are involved in writing packing algorithms or writing a control system for enabling picking. So we have several other teams or trying a new arm, a new gripper. So all of these teams innovate and they come and give us some use cases that they'd like to try. One of the examples that I already mentioned was the barcode scanner. So if we want to be efficient with our picking and placing, how fast can we scan the barcodes? That was one of the challenges that came by. So if we picked that up as one of the feature, we then went and did some sort of solution design on understanding where could we place it, or could we give the functionality for our users so they can enable wherever they want to place the barcode and trial and error using our simulation. So that's what we did. We did a design and came up with some high-level estimates. Then that goes through a software development life cycle, which is a few engineers work on it. They develop the code. And then we go through the testing and validation of our implementation to make sure it replicates real hardware. And then finally, we give it to our users. We release it, and then we support the phases so the users can use it, and then they can build more innovation based on it. And they can go back and build their hardware, update it. And yes, they came up with good barcoding, barcode scanner positions as well, enabling them. So that's how we do a feature development lifecycle within my team. Quickly also going to go over what sort of agile planning we do. We use the Scrum model. So there's a backlog of features and requirements that sits in our product backlog. We use Jira. And then we do something known as a pre-planning, which is we prioritize the work and define sprint objectives. So I'm involved in defining sprint objectives. We might pick like 3 objectives to complete over 3 weeks. We plan that, we prioritize it, define the objectives, which we call as sprint goals. And then during planning, we look at what are the work that's involved to accomplishing these sprint goals. How can we actually deliver them on time? So we break down the work during planning. We then go ahead and work on it for the next 3 weeks, which is the sprint period. And then finally, we look into sprint demos. So at this point, we invite leadership, senior management, other users to come and see what we've worked on so we can demo what we've done, a new feature. And then finally, we do a review and retrospective. What did we do badly? You know, how can we improve? What did we do well? How can we continue? So we do a sprint review and a retro. And the process goes on. We deliver code release. We make big announcements to say, hey, a new release of our product is here, guys. Try and give us feedback. And then the cycle continues. So that's a part of where we are. That's how we do planning within my team. And there you go. I have a cue to finish early. So I'm going to move on to careers in Ocado technology. So we are looking for technologists always. I'd like you to head over to the exhibition stand. There are amazing people there to talk about the different opportunities we have. So, you know, to get some insight, I very much encourage you to reach out to our Ocado colleagues. Dr. Radhika and Laura are there as well. So, yes. And there you go. That's the end of my presentation. Thank you guys for listening. Any questions?
Thank you. We've got a couple of questions that we could take. Would anybody like to ask Tafline something? There's one over there.
You said we could ask about the jar of life during the Q&A session. So I wanted to know more about that.
Yeah, absolutely. There's lots of YouTube videos on that as well, but I would definitely let you know my take on it. So the jar of life is very much similar to a jar, and you fill the jar. And what do you want to fill the jar with? It's basically like your life, you know, what do you want to do with it? There is stones, there's pebbles, there's sand, and there's a lot of water. So each part defines what it is to you. So for me, the first things I fill in there is the things that matter to me. To someone, it might be career. To me, it is my family, my health. So those are like the big things that I fill in. So whenever I am in a predicament, I prioritize, you know, I have an opportunity at work, have something going on with my family, and then it makes my decision making quite easy because I prioritize my family at that point, and everyone has different priorities, guys. This is how I take it. And then the next ones is your health and other things as well, social activities, friends, which you prioritize, and then work comes after that. So it's more like, you know, filling a jar. If you fill the jar with the less important things, like sand, for example, then it fills up quite quickly. But if you fill it with rocks and then pebbles and sand and water, you would still be able to put everything in. So that's my take on how I take the jar of life. Hope that helps.
There's one right at the back.
Hi. I was just wondering, in terms of sort of robotic simulations, I know that simulations can be really computationally expensive and very difficult to set up. And so I'm just wondering, right now in industry, what are like the most limiting factors in terms of setting up simulations, especially for such big systems?
Thank you. That's a really lovely question. So you're right. Simulation, there is sim to real, but I still feel the sim to real gap is yet to be reached. So that gap is always there. With generative AI, there's a lot that we could accomplish. So simulation could get much more easier and simpler in the future. But currently at this point, especially with, let me talk about manipulation. So manipulating with soft bodies, that is a challenge. You need to know how soft a body is, how hard on your touch. So that sort of manipulation to reproduce in a simulation can be tricky. The exact comparison on weights and how we process force torque, for example. You know, it lifts up, the robotic arm lifts up, it moves, but what force does it go? The velocity it builds. Comparing that to a real hardware can be a challenge, so there's plus or minus some errors there as well. And finally, the physics. There are several different physics engines right now, but there isn't one that does everything the best, because there's so many. There's Drake, there's Isaac Sim, there's also game engines, but everything has particular specialities, but all of them combined, we need to have a simulation that combines all of them. For instance, for segmentation or imaging, some of the engines are much, much more nicer for photorealism. However, they might lack the ability to grasp deformables better. So there is always this challenge on, which physics engine you choose over the other. So how we address the problem is we look at use cases. Some of our users are only concerned about testing, just testing and validating their software. To them, photorealism is not important, so we provide lesser fidelity images and systems so they can test. However, for some of our users who is keen on vision, they are looking at sensing, they are looking at grasping, and they would like depth images and real RGB images that they can convert. So to them, photorealism is keen, and we would be like working on enhancing the visuals. So it's a play around which ones you choose at that stage. Did that help? Thank you.
Okay, so we have another speaker, so I'm going to suggest that we stop here, and then if you've got any extra questions, you can find them on the store, and they'd be delighted to hear from you.
Absolutely. Thank you very much.
I'd like
guys.
to thank Tafline again.